Hey boys and girls, today your math lesson comes from Module 15, Lesson 6. It's on pages 393 and 396 of your workbook. If you don't have your workbook, don't worry, everything will be on the video, and then your work will actually be in a Go Formative question set that will have all the questions listed on them. And so all that will be available for you to show your work and get that done. Okay, in this lesson, we're going to solve problems using bar models. When you finish with this lesson, you want to be able to use a bar model to solve a multi-step problem that uses multiplication. All right, now don't forget that you have that superpower to control time, and if you need to stop the video and look at it again, you can do that. All right, so I want to remind you what is a bar model. Now, we've talked about a bar model in class. A bar model is just a way to break up a problem into parts that equal a total. So in this example right here, I could have a part plus a part equal the total. And here's an example right here. Maybe I don't know the total, but I know the two parts. And so I could combine those two parts by adding to find that missing total. Okay, or maybe I have several parts that add up to the total. And I know what the total is, but I only know some of the parts. I can find that missing part by using subtraction. So in this case, I have 10 and 10, and some other number equals 25. And so I would have to take the total and subtract out the 10 plus 10, which is 20. And then that would equal the 5, the missing number. So these are bar models. We're going to use these to set up equations to solve multi-step questions that use multiplication. Okay, we're going to start with a pretty simple problem. I'm going to read it to you, and then I'm going to remind you how to go through this one sentence at a time to get the information you need to solve the problem. In this problem, we have Lucinda who buys 4 heads of cauliflower that weigh 1.88 pounds each. She buys 1 bag of potatoes that weigh 4.5 pounds each. What is the weight of Lucinda's vegetable purchases? Use a bar model to solve. All right, so I'm going to represent the things that she has bought in this bar model. And I'm combining the weight of one food with the weight of another food to get a total weight. So I'm combining like things. Now I've represented 4 heads of cauliflower by writing out the weight of 1.88 4 different times. There's 1 head, 2 heads, 3 heads, 4 heads of the cauliflower. And then over here, I've put the weight of the 1 bag of potatoes. All right, so I know that all of these will be combined together to get the total weight. I could add them all up, or I could use multiplication. Since this 1.88 is the same 4 times, I can write that using a multiplication fact. 4 times 8. Then add the potatoes, and that's going to give me my total weight. All right, so I went ahead and multiplied that 4 times the 1.88 pounds, and I got 7.52, or 7 52/100ths of a pound. And so after I've multiplied that, I'm going to rewrite it and then add my 4.5. Now when I add 2 decimal numbers, I just want to remind you that we have to line up the decimal points. And so it's helpful if we are using a T-chart or a quick place value chart to write that. So I'm going to take my 7.52, put my decimal point on the line to keep them lined up, and then I'm going to add 4.5 to it, lining up tenths with tenths. Then I can annex a 0 here if I wish. And I get 2, 10, carry. 7 and 4 is 11, plus 1 more is 12. On adding and subtracting, my decimal point comes straight down. So I know that the combined weight of all that food is 12.02, or 12 and 2/10 or 2/100 pounds. To get the total weight. Okay, I want you to look at a second problem that is similar, but just a little bit different, because we're going to have to use some subtraction instead of addition in this bar model. All right, so take a look at this one and see if you can figure out how we might represent that in a bar model. Okay, in this problem, we have a giraffe that can cover 1 mile in about 6.4 minutes. An elephant can cover 1 mile in about 8.2 minutes. About how much longer will it take the elephant to cover the 3 miles than the giraffe? All right, so we identify what the question is. How much longer will it take the elephant to cover 3 miles than the giraffe? So when I know how much longer, I know one number is going to be larger than the other, and so I'm going to subtract to find the difference. Now let me look at the rest of the problem to find the quantities that I'm going to be using. Well, I know a giraffe can cover 1 mile in 6.4 minutes, and an elephant can cover it in 8.2 minutes, the same distance, 1 mile. But I want to know, how far will they go? If they go 3 miles, how much time will it take to cover 3 miles? And so I'm going to represent that in this bar model. Now I know that the elephant's going to take longer, because 1 mile takes him 8.2 minutes. And that's going to happen 3 times. So I'm going to put my elephant on top as my total, because that's going to be the larger number. So I've written that as 8.2 plus 8.2 plus 8.2. Or that could be written as 3 times 8.2. Now the giraffe, he's a little faster. So I know that's going to be 6.4, another 6.4, and another 6.4. That's going to represent the 3 miles. And I know that's a little bit shorter amount of time than what it's going to take the elephant. And so this question wants to know, how much shorter is that time? It's going to take the elephant longer, and I want to find that difference. I'm going to write that as an equation. So I'm going to use that bar model and say, okay, I've got 8.2 written 3 times. So I'm going to write that as 8.2 times 3. And then I'm going to write my 6.4 times 3 for my giraffe. I'm going to subtract those two quantities to find out how much longer it's going to take the elephant. So let's do that. So first I've done the multiplication, 8.2 times 3, and I end up with 24 6/10 of a minute. Now remember, when you multiply decimal numbers, you multiply first, and then you count the number of decimal places in each factor. I only have 1 decimal place, so I need 1 in my product. All right, then 6.4 times 3, I get 19 2/10. And again, I simply have tenths in my product. So now I need to find the difference between these two. I see that the elephant does take longer, and I'm going to subtract to find the difference. So I know that equation is going to be 24.6, which is the product of the first part, subtract 19.2, and that's going to give me my difference. Now remember, when we subtract, we're going to line them up, we're going to stack them. And when we line up, we can use a T-chart or a quick place value chart, whichever one you want to use, to subtract to make sure we line up our place value positions. 6 minus 2 is 4. Decimal point comes straight down. 4 minus 9, I can't do that. I'm going to have to regroup and make that 14. 14 minus 9 is going to be 5, and 1 minus 1 is 0. So I know it's going to take the elephant 5.4 minutes longer than it does the giraffe. Okay, if you need to re-look at these models to see how we use them to write an equation to solve a multi-step problem that involves multiplication. Stop the video or rewind it and take a look at it. Good luck on your work on the Go Formative assignment.